Okay, hello everyone. We are continuing the section 4.4 notes for class. And I wanted to talk about, so we started talking about the method of undetermined coefficients, which I think you guys were okay with. And we talked about the conditions for your g of x and what forms it needs to take. So go back over the notes so you can see what forms. But now we want to just look at some examples to make sure you all are good. And so I want to take this first example here, y double prime minus y prime plus y equals 2 sine of 3x, right? And so our first thought in terms of solving this for finding the particular solution, if we want to find the particular solution. So if it just said find y of p, well, our first thought would be what? Probably a sine of 3x, right? Sort of similar to how we set up the other examples we did in class. But actually, let me do this. So our first thought would be y of p equals a sine of 3x, right? And so y of p prime then would be what? 3a cosine 3x. And then yp of double prime, it would be negative 9a sine of 3x. If you're not sure how I'm getting these, you need to go back and review the chain rule property with trig, and you'll see how to set that up. But hopefully you guys are comfortable and see that. Now our issue is we don't have a cosine, right? There's no cosine on the right hand side. And so the actual setup, so that would be our first thought. Whenever there's a sine or a cosine, the actual solution setup, actually you need to bring them both in. So a sine 3x plus b cosine of 3x, okay? And so once you do that, we look at yp prime, which you should get 3a cosine 3x minus 3b sine 3x. And just for review to make sure you all are good with the derivatives, you should maybe pause the video and see if you can do it on your own and come back and play. And then negative 9a sine 3x minus 9b cosine of 3x. Okay, so that's how you should set it up when your g of x is a trig. Although we're going to do another example where you have to, there's a glitch in this method. So there is a glitch in this method that we'll look at another example to see that. But that's the general setup for that. Okay, so now just plugging in our values on the left, and we know it's going to equal the right hand side there. And you can go ahead and pause the video and write this down, or sort of pause it and do it yourself and then confirm your answer here. But what we get down to, and I'm trying to save time on the video, what we get down to is that in front of the sign, this represents the coefficient, right, in front of the sign. And so on the right-hand side, we want that to be 2. So 3b minus 8a, we want to equal 2. And this is the coefficient for cosine, but there's no cosine on the right-hand side, right? So we want negative 8b minus 3a to equal 0. Okay? And then from there, you go ahead and solve. And so you should end up with a giving you negative 16 over 73. And b will give you 6 over 73. And so your particular solution, because that's what this question asks for, is negative 16 73rds sine 3x plus 6 73rds cosine 3x. Okay, and of course with any solution, you can check by taking this derivative here, the first and second, and plugging it back in on the left-hand side. Ooh, that's a lot going on there. Plugging it on the left-hand side to get what's on the right-hand side. Okay. I don't ask you to do that, but if you're not convinced that that's your answer, then you can check it that way. Okay, so let's look at another example. So for this, this is asking us to solve. So therefore, we want the general solution, which we now know that the general solution is made up of the complementary plus the particular. And you should always find the complementary first. I'll tell you more about that, especially when we look at the second example that we're going to do, or the last example we're going to do. But here, that should be your process. So if they ask you just for the particular solution, then you start with the particular solution, of course. But if they ask for the entire solution, you should always start with the complementary first. It's going to be very important to do that, and you'll see it more so in the last example we do. So for y sub c, right, the complementary, that means we need to solve y double prime minus 2y prime minus 3y equals 0, right? And we know how to do that. There are different methods. One of the most simple ones is just look at the auxiliary equation. And this one is easy to factor. If not, of course, we always have our beautiful quadratic formula to our advantage. But this one can be factored. So m is 3 and negative 1. So we have the distinct roots, right? Distinct real roots. So that means our complementary function equation will be c sub 1 times e to the 3x, right? Plus c sub 2 times e to the negative x. All right, so we're done with our complementary. That's nice. Now we have to find our y of p. But notice what's going on. It's sort of, we have a linear inequality in there, and then we have this exponential function in there, right? And it's a x e to the 2x, right? Which, in terms of forming, so we have to, what we call forming by superposition, we put those together. So we're going to form yp by superposition. Okay, and so we can look at this as, so here we have this linear factor, right? And then we have this, well, x times exponential, right? And so, and I look at it like that because remember when we think about, well, when will that come in, that x times e to the 2x, that comes in when we have a repeated root, right? And you can go back over your notes to see when we have a repeated root. And don't write this down, but let's say we have a repeated root and let's say m is negative 1, right? With multiplicity 2, right? Then that means our final answer, if you recall, is going to be c sub 1 e to the negative x plus c sub 2x e to the negative x, right? So we sort of build up into that. We're going to have to do the same thing when we form this by superposition. And so what we're going to do then, y sub p, we actually going to break that down into y sub p1 plus y of p2. We're going to bring it all together, of course, but that's how we want to look at it. And so the setup for the linear factor is just going to be ax plus b, okay? And then so plus, since I have an equal sign there, I might as well put it on vertically, plus, well, y sub p2, that's this right here. And to build that up, it would be c x e to the 2x. I'm sorry, I'm going too fast. I'm going ahead of myself. It would just be c e to the 2x plus dx e to the 2x. If this doesn't make sense, go back and look at it in your book. I'm just sort of giving you the nuts and bolts of it, but if you want a more thorough explanation, of course, go back and see if it makes sense by filling in the gaps. But that's the setup here. So y sub p is going to be ax plus b plus, we can drop the parentheses. I just wanted to put the parentheses to clearly show you the two. We're sort of bringing two different types, right, together to create our y of p. So now I would say, since you know what y of p is, I would say you should pause this video and try to find, we proceed as usual, so we're going to have to find the first and second derivative of this and then plug it in and then balance our equation. So try to do that and then come back to see if your solutions are correct. Okay, so these are my final solutions. Of course, there was a little simplification going on, so make sure you simplify everything completely. But check your answers to see if you receive these. And now I want you to go ahead and plug this into our y double prime minus 2y prime minus 3y. And it should equal 4x minus 5 plus 6x e to the 2x. And again, go ahead and pause the video to try that and come back and check your solution. All right, so hopefully you received this. So I sort of grouped it together according to their terms. So negative 3dx e to the 2x plus the coefficient 2d minus 3c e to the 2x minus 3ax. And then the constant is negative 2a minus 3b. And so that means in terms of looking at the right-hand side, 4x minus 5 plus 6x e to the 2x, right? Then negative 3d should be equal to what? 6, right? Good. 2d minus 3c should equal what? 0, right? Because there's no e to the 2x on the right-hand side. Negative 3a should equal 4. And then our constant, negative 2a minus 3b, should equal negative 5. So again, just go ahead and pause and find your solutions. All right, welcome back. Your solutions, you should have received A is negative 4/3, B is 23/9, C is negative 4/3, and D is negative 2. And so the final answer to this problem, well, remember from the beginning, our complementary solution is C1e to the 3x, right, plus C2e to the negative x. Then, going back to our, remember, now filling in our values, so it's going to be plus, or a is negative, so let's put minus 4/3 x, b is plus 23/9, C is negative 4/3 e to the 2x, and D is negative 2x e to the 2x. All right, and so we have our final answer. And hopefully that made sense. We're going to start the last problem that I'm going to do in this section. After that, actually, before we start that, let me post up something. So I think I'll present a couple things, and then I'll start a new video to do the last problem. All right, so it's actually in your book, but I wanted to present it to you all on here so you can write down in your notes as well. Okay, so I wanted to show you all, and this is in your book, and there's a table, but I wanted to show you sort of the particular solutions and the trials so you can sort of see. I'm not going to go over all this list, but you should put this in your notes, so when you're doing the problems, you'll know which sort of trial to begin with. Like I said, there is a glitch in this, which we're going to do a problem to show where the glitch could be. But you see, if you have a constant, then your form of your particular solution will just be A. If you have a quadratic, it's going to be set up ax squared plus bx plus c. Although, this is missing an x term, you still want to make it complete for your setup and work from there. And let's see, remember, if you have a sine or a cosine, you set it up including both your sine and cosine terms. Let's see, something like that. You see how it's a linear, and then the term, if it's x squared, then x squared e to the x, then it's ax squared plus bx plus c, and then e to the 5x. Okay, and I actually realized that I explained something incorrectly. I want to go back. When we talked about setting up this, so this is part of growth mindset, reinforcing the growth mindset, right? Because, I learned from my mistakes, and now I want to go back and correct them, make sure it's clear. So the reason why we set this up like this is actually, this is a linear factor. All right, so I'm glad I actually messed up, so make sure it's clear. This is a linear factor, and so the setup actually is, in this case, C, well, and the way I have it, it's sort of set up backwards. It's dx plus c e to the 2x. And then what happened was it got we used the distribution property, and that's how we came up with that. So it's not from building upon what I said earlier. So forget what I said earlier. Looking at that table, I want to make sure it's clear. So hopefully that's clear. So now if it's a linear times exponential function or a quadratic times exponential function, you set it up with either a linear factor, quadratic factor, and the likes. Okay. So I hope, because I think how I explained it earlier might have been a little confusing. So hopefully this makes sense now in looking at that table. Okay. I'm going to stop the video here. And again, so you need to, all these notes should be in your own notebook. But these should be helpful to you all in learning how to set up the trial solution. But I do want to stop here to show you where there's a glitch in this method.